Hello guys, welcome back. In this lecture, we are going to cover the typecasting as well as the type conversion. So in general, the typecasting is also called as narrow casting or downcasting, explicit casting or manual casting, anything we can call. In the same manner, the type conversion can also be represented as automatic, widening, upcasting as well as the implicit casting. So the basic difference between typecasting and type conversion is this has to be operated on the various data types. We discussed what are the various data types we have. So in general, when we come to the primitive, secondary we are not going to discuss here. So in the case of primitive data types, we have Boolean and also we have number. So when we come to the Boolean, we are going to have either true or false. That is, true means 1, false means 0. So when we come to the number here, we have integer type and also we have floating type, byte. So in integer type, we have byte and we have short, then integer, then long. So when we come to the floating type, we have float as well as double. So when we come to character type, we have character only. So these are the various data types we have, what we discussed in the previous chapter. So why we are recapping here is, whenever we are applying typecasting or type conversion, that has to be applied on these data types only. 8 bit of memory is going to be allocated or 1 byte of memory is going to be allocated. As we are saying 8 bit, the range should be minus 2 power 7, 2 cap 7 I am writing here, 2 power 7 2 plus 2 power 7. So this is the range here. As it is 8 bit memory is going to be allocated, the range is minus 2 power 7 2 plus 2 power 7 minus 1. In the same manner, in the case of short, the memory it is going to be allocated is 2 bytes here, that is 16 bit. 16 bits of memory is going to be allocated. So for that, minus 2 power 15 to 2 power 15 minus 1. Right? Minus 2 power 15 to plus 2 power 15 minus 1. In the case of integer, 4 bytes or we can say 32 bits. And the range is the same, I am copying here. As it is 31, we are writing here 31 minus 2 power 31 2 plus 2 power 31 minus 1. In the case of long, that is 64 bits of memory is going to be allocated here. So in the case of 64, as we are writing here, minus 2 power 63 to 2 power 63 minus 1. See, when you observe this, when it is 16 bits, we are writing 2 power 15. Whenever 32 bit, we are writing 2 power 31. Whenever it is 64 bit, we are writing 63. Means we are reducing 1 bit here. Why we are reducing here? The reducing bit will be used for sign. As we are writing positive values or negative values, whenever we are writing the value, by default the value symbol is plus here. And if you want to specify any negative value, we need to write minus just before that number. So to represent that symbol or positive sign or negative sign, we are using 1 bit here. That's why whenever it is 16 bit, we are writing 15, and whenever we have 32 bit, we are writing 2 power 31, and whenever we have 64 bit, we are writing 2 power 33. In the same manner for float and double also. Now, so these are the types, these are the various data types we are going to operate on the typecasting as well as the type conversion. So whenever we are using typecasting and type conversion, in general, whatever the primitive data types we have here, whatever the data types we wrote here, so on primitive data types, we are going to apply the type conversion. Whenever we are going to use typecasting, usually the typecasting is applied on the classes, interfaces, objects to convert one type of data into another type of data. So as the conversion as well as the casting both are used to convert that one type of data into another type of data. By default, the Java will not convert all types of data into another type. So Java has some restrictions when it is converting one type of data into another type of data. So to overcome that, we are going to use the typecasting as well as the type conversion. So whenever we are using typecasting, as we are saying, explicit conversion means what? We need to convert, the user has to convert the corresponding data type into another data type. And whenever we are using type conversion, it is implicit. That means the compiler will convert the data of one type into another data type. So here, if you take, let us assume, we will take one example here, and by taking one data type each, let us assume, so I'm taking various data types here. Let us take byte B, then short S, then integer I, then float F, long L, double D, and character ch, boolean B. So boolean BL I'm taking here. Now, so these are all implicit declarations we can call here, as we can assign some values here and we can do some kind of conversions here. When we are operating on this data type, as you can see, as we know, the byte type is accepting, or the for byte type 8 bit of memory is going to be allocated, for short 16 bit of memory is going to be allocated. So we can store byte into byte, the whatever the data we have in byte, into the variable called s, which is of type short here. At the same time, the short data can be stored into integer, integer can be stored into float, float can be stored into long, long can be stored into double. But in reverse, it is not possible here. So we can call this as a implicit conversion. For example, as we can also assign like this. For example, I'm writing here byte b equal to 10. There is no error here. S short equal to some 345, integer I equal to 765, like this we can write here, and float f is equal to, as we know, the range here, and long L equal to, like this we can write here. And as you can see, if it is exceeding, it is showing the out of range. If I remove one string, okay. So long L, like this also we can assign here. Now, whenever you are writing here, for example, here I am writing like this, S equal to B I am writing. What is going to be happen here? Nothing is going to be happen. So S equal to B. So what is S here? Short. And what is B? And 10. So we can store boolean byte value into short. At the same time, we can store short value into integer, integer value into float, like that. We can store any type of data into another type of data, because as it is in the range. So now when we go for explicit conversion, for example, so whenever we are writing the explicit conversion, let us assume instead of writing S equal to B, I am writing B equal to S. So I'm writing B equal to S. Yeah, S is of type short type and B is of type byte type. And for short, we know there are 2 bytes of memory is going to be allocated here, and for byte 1 byte of memory is going to be allocated. So whenever we are trying to convert the short type into byte type, the compiler will check whether it is possible to accommodate the memory which is allocated for short into byte type. So definitely, whatever the memory allocated for short, that is 2 bytes, we cannot accommodate the 2 bytes of data into 1 byte, as for byte 1 byte of memory is going to be allocated. So for that, it is going to generate an error here. So for that case, what we need to write here, I am converting the short type into byte type here. So for that, I am writing byte, byte means. So for this particular line, I am going to convert the short type into byte type. So before this line, S is of type short only. After this line, S is of type short only. But during this compilation process, when this line of code is executing, at this particular line, the type of S becomes byte. So this is called explicit conversion, or we can also call this as a type casting, because we are doing here. The conversion is done by the user here, and for this particular line, I am converting short into byte. So that's why we can call this as a explicit conversion, or we can also call this as type casting. So whenever we are doing type conversion, the compiler will do. Whenever we are doing type casting, the user has to do. And during compilation process, if the data type, one type of data will be converted to another type of data, in general, the right hand side variable, whatever the memory required for right hand side variable, should be less than the memory required on the left hand side variable. So in that case, there is no problem we are going to get. So directly the compiler will convert that into another type. As we saw in the example, we can store integer value into float. So f is equal to I, we can write here, because I 4 bytes, float 8 bytes of memory is going to be allocated here. So that's why, so we can store the integer value into a float. For that, no conversion is required. You can directly write f is equal to I, so that the compiler will convert integer type of data into float type, because the integer type memory can be easily loaded into float type memory. But if you want to store float value into integer variable, in that case we need to convert manually. So for this, the compiler will not do anything. It cannot able to convert the longer data types into shorter data types. So for that, we need to convert explicitly, or manual conversion we need to have, or typecasting we need to have. So we need to convert like this. In the same manner, if you want, as I said, long double if we take. So if you want to store long value into double, d equal to L we can write. So there is no problem here. We can call this as a type conversion. But in reverse, instead of writing, let us take, I'm taking here. So instead of writing d equal to L, this is no error here. So L value is assigned to d. We can call this as a type conversion. So when we write L equal to d, for example, in this case, we are going to get an error here, because it is having double type and it is having long type. Definitely, it is going to have the more memory. And let us assume I'm taking I equal to d. So double value I want to store into integer variable. So it is not possible. For that, I'm converting this into integer type on temporary basis. On this, for this particular line, we are going to convert the double type into integer type, so that the double data, whatever the value we have in double data, will be stored into the variable called I. And now here we can get one doubt here. Whatever the larger memory we have, that larger memory value we are going to store into smaller value. So in that case, definitely we are going to lose some kind of data. So the data losses will be happened during the typecasting process. And one thing we need to remember here, that is, whatever the Boolean type we are going to operate, whenever we are going to type Boolean type, whenever we are going to operate the Boolean type, and we need to remember that we cannot cast the Boolean value, right? We cannot cast the Boolean variable into another type. So for Boolean variable, typecasting will not be applied. At the same time, we cannot insert any other type into Boolean. We cannot convert Boolean value into another variable type, and at the same time, no other variable can be converted into Boolean type with the help of typecasting. I'm taking one more variable, byte b1, and also I'm assigning some value called 10 here. Now we can do some kind of operations here. We can do some kind of operations on that byte variable. Now what I will do is b1 equal to b1 plus 10 I'm writing here. Then as you can see, when I'm writing this, we are going to get an error. What is that error here? Cannot convert from integer to byte. We cannot convert from integer to byte we have here. So when we run this code, as you can see, we are going to get an error here. What is that? Type mismatch, cannot convert from integer to byte. But there is no integer variable. We took only byte variable here, byte b1 equal to 10, and we added something here. We are displaying the value. The basic reason for this is, whenever we are performing addition operation on byte and short as well as character, whenever you're performing any operation on these types, it is going to be it will convert that data into integer. Means whenever you are performing any kind of operation on byte, short as well as character, as we declare the variable as a byte here, and we are going to perform a kind of operation called addition operation on the byte variable. In the same manner, if you perform any operation on short or character, then also this corresponding b1, as we are operating on b1 here, the b1 will be, even though we declared as a byte here, when you're performing addition operation on b1, this b1 is going to be converted into integer. Now, if I write the same thing here, if I'm writing integer, we are not going to get any error here. Integer, if we declare the b1 as integer, we are not going to get any error. In the same manner, For the same case can be applied for character as well as the short also. So make sure, remember this point very carefully. Whenever we are performing any kind of operation on byte, short as well as character, that particular type will be converted into integer. For example, you may get one doubt here. If you perform, we declare one variable as integer, then we are trying to operate some kind of operation. In that case, it is going to convert that into the next layer. For example, in the case of byte, short as well as character, when you are performing operation on these data types, it is going to be converted into integer. When you are performing the operation on integer, it is going to be converted into float. When you perform operation on float, it is going to be converted long. When you perform operation on long, it is going to be converted into double. Like this, the automatic conversion we are going to have during the compilation process or during the execution process. So whenever we are operating on byte, short as well as character, the next higher data type is integer. So these three will be converted into integer when we are performing any kind of operation. The same manner, integer will be converted to float and float will be converted to long, long will be converted to double when we are going to perform any kind of operation. For example, I'm taking byte b3 equal to b3 plus, let us take, I'm taking long type. So whenever we are writing byte b3 is equal to b3 plus l, as we can see, we are getting error here. We are getting error. So static reference and cannot convert means what? We cannot convert the byte data when we are performing some kind of operation on byte data. This b3 will be automatically converted to its higher type. What is the higher we are using? Long here. So b3 will be converted to long. For example, if I am using double here, I am using double variable. In that case also, the b3 will be automatically converted to double type during the execution process. So like this, it is going to convert into higher type here. For example, let's take one simple example here. I'm writing like this. I'm removing this here. As we are going to get an error, just I'm removing this. I'm keeping in comment line. Then, for example, so I'm writing like this here. System.out.println. So in single quotes, I'm writing A plus, and also in single quote, I'm writing B. So again, we can see here, we are getting error here. Syntax error, insert, like this it is asking. If we take character also, let us take, I am taking one character variable here. Character A equal to small a, I am writing here. And then character B equal to small b, I am taking here. Now, when we performing a plus b, as the Java, in Java, plus is the concatenation operator, and we thought that we are going to, this statement is going to produce an output called ab or a plus b. But in this case, as it is considering plus as addition operator, and as we know, the ASCII value of capital A is 65, and then plus ASCII value of capital B is 66. So it is going to produce the result as 131. Like this, we are going to get here in this case. And now, one important thing we are going to discuss here, that is called wrapper class. For example, taking integer variable here, 4 bytes of memory is going to be allocated here. 4 into 8, 32 bits of memory is going to be allocated. So minus 2 power 31, 2 plus 2 power 31 minus 1. So this is a range here. Let us assume I want to find the maximum value. Just for our understanding, I am taking the maximum value here. So for that, I am using integer m is equal to integer dot max value. That is wrapper class we are using here. And now let us print first the max value here. So when we run this code, as we can see, this is the maximum value we can have here. In the same manner, let us take one more variable I am taking, integer n equal to integer dot min underscore value. So for this, we are going to get minimum value. So I'm copying this one. So I'm writing n here. Let us compile this program. As we can see, this is the minimum value and this is the maximum value. Now, what we are going to do is, I'm doing some kind of operation in this case. Here, we are going to do some kind of operation on the variable. So here integer is a wrapper class here. I hope you might have some idea about wrapper class here. So integer is wrapper class, and with the help of wrapper class we are accessing the maximum value, and that value is to be stored into m. So whatever the maximum value, the last value which is in the range of integer, that particular value we are going to store in m, and what is the starting value we have, that particular value we are going to store in n. Now here m is the maximum value here, that means this value minus 2 plus this is the last value we have here. Now I'm writing here m is equal to m plus 1. What is going to be happen, as let us assume we have a circle here. It means if it is starting from 0 or 1, so 1 2 3 4 5 6 like this, and minus 1 minus like this, we are going to get here. So if you complete one circle, that is ranging from minus 128 to plus 127. Now here the question is, whenever we are using, so whenever, for example, I'm using here one operation, let us assume the byte is 127. So what I will do is byte b equal to 127 I'm writing here, then b equal to b plus 1 I'm writing. So what is going to happen, we need to get 128, but there is no 128 here. Whenever it is reaching to 127, it has to come to minus 128, minus 127, like this we are going to get. So let us see here. Now, in the same manner, whenever we are taking one integer value, maximum value I am taking here. What is the maximum value here? 2147483647. That is the maximum value we are going to store into the variable called m. Now, what I will do is, I am doing m is equal to m plus 1. I am adding plus 1 for this. So, whatever the maximum value we are getting here, this is the maximum value we are getting. M is equal to 214748. 3647. This is the value we are going to get. So when we add plus 1 here, how much we are going to get? We need to get 48. But let us see what is going to happen here. As you can see, when we are adding plus 1, we need to get 48 here. But what we got here? The minus symbol, we are going to get 48. That means when it is reaching to last number, again it has to come back for the minus value, as we said here. So it is starting from 0 when the maximum value, and again minus values it has to start here. So likewise, if we take minimum value also, for example, I'm writing here for our understanding, the max value equal to, and here the minimum value equal to, and also I'm writing n equal to n minus 1. I'm writing here. Right, system.out.println the max value after adding 1 here. So if we compile this program, what we will see? We will see, as you can see here, the maximum value is 47, but when you are adding 1, we are going to get minus value. At the same time, minimum value is minus last 48 here. When we are subtracting minus 1, we are going to get plus value here. As you can see, this is called wrapping bits. So whenever we are reaching the minimum value, we are going to get next value is 0 again. And again, when we are reaching the maximum value, when we are adding plus 1, again it will come to starting point here. So this is the last value. So like this, the wrapper class is going to be worked in Java. As you can see here, the minimum value and maximum values are stored in m and n. When we are adding plus 1 for the maximum value, it has to come back for the initial value, as we saw in the example. For example, if we take the character range here, it is starting from minus 128. Minus 128, minus 127, 126, like that we are coming 0 here, and again 1, 2, 3, 4, 5, 6 up to 127. When we are adding 1 plus 1 for this 127, it is moving to right hand side here, but the right hand side the value is minus 128. So in general, when we are adding plus 1 for this, we are going to get 128, but there is no 128 in this range. So what it will do, for 127 it will add plus 1 here. When it is adding plus 1, we are getting minus 128 here, minus 128, 127, like this. If I'm writing, if b is equal to 127 and b is equal to b plus 1, I'm writing b plus 10, I'm writing, for example. So what is going to happen, from 127 the cursor is jumped to 10 locations here, like this. Let us assume if we have the minimum value and maximum value, when I'm adding m equal to m plus 1, what is going to happen here? Once it is reaching the maximum value, the cursor is moved to the right hand side here. As the range is completed, again it will start from minus this value, initial value, to the maximum value. So when we are adding plus 1, we are going to shift to the negative value, starting from minus 47, and it is reaching to 0. And again 1, 2, 3, 4, 5 up to 47. So this is the range we have here. So minus 48 it will start here, and last 47 we are going to get. When we are adding plus 1 for that, there is no range here. For that, it is coming back to initial value. In the same way, if we write plus 10 here, what is going to happen here? The 10 locations it is going to move here. Let us see what is the output we are going to get for this case. As you can see here, m is equal to m plus 10. The maximum value is 47 here. When I'm adding plus 1, after adding, as you can see, minus 39. So it is shift the 10 locations to right hand side. In the same manner, for minimum value we took n here, when I'm taking n is equal to n minus 1, when I'm subtracting 1 from the minimum value, as it is the starting value, when you're subtracting 1, the cursor had to move back here. When it is moving back, we are getting the maximum value here. So that is about wrapper class. So when we come to the major differences between typecasting as well as the type conversion. In the case of typecasting, as you can see here, these are the major differences in typecasting as well as the type conversion. In the case of typecasting, the data type is converted into another data type by the programmer using casting operator. As we are writing some bracket here, any data type we are writing in bracket, that particular bracket parenthesis will be considered as the typecasting. In typecasting, as in the case of type conversion, data type is converted into another type by the compiler. The second difference is typecasting can be applied to the compatible data types as well as the incompatible data types. But type conversion can only be applied on compatible data types. That is, smaller data values can be stored into larger data types, but reverse it is not possible. Third difference, typecasting can be, the casting operator is required to convert one type of data into another data type here, and here there is no casting operator is required because we are storing the small value into larger data type. When we come to the next difference, in typecasting, the destination data type may be smaller than the source type, but in this case, the destination data type cannot be smaller than the source data type because the compiler is converting here, so it should be more. And when we come to the next difference here, takes place during the program designed by the programmer and but done at the compile time. And also called as narrowing conversion, and here we can call this as widening conversion. And the typecasting is often used to coding as well as the competitive programming works, and here also used in coding as well as the competitive programming. It might cause incorrect answer. And more efficient here, typecasting is more efficient and the type conversion is less efficient. So this is about type conversion, typecasting, and wrapper class. So if you have any queries, simply comment on me so that I'll try to reply. Thank you. All the best.